This story is familiar to absolutely all aviation enthusiasts. Anyone who has ever been to any major air show at least once. The combat aircraft is taxiing to the runway, and bright streams are bursting out of the engine nozzles. Heated gases, and he ascends into the sky in just a few seconds. Meanwhile, the noise and clatter are so loud my hands just want to cover my ears. This is Fast and Furious, special operating mode of the turbojet engine, which increases his desire. The increase is very substantial, from 30 to 70% depending on the specific model. But the payment for its use is also quite substantial. Fuel consumption has increased significantly. Yes, and the structure of the engine, a priori, it has a more complex structure. However, without the presence of the afterburner mode, a modern combat aircraft simply cannot do without it. An additional thrust is needed for quick speed gain, including supersonic, and also for execution, active maneuvers with high overload, so as not to lose this very speed we've gained, literally in just a few seconds. Looking at the vibrant work of the turbocharger mode, reasonable questions may arise. It seems like, and how is everything set up, and on what principles does it work? Or how quickly will the fuel run out on the airplane? If you don't turn off Fast and Furious immediately after takeoff at all, what are these rings visible in the stream of gases coming out of the nozzle? And for what reason? Her glow has different shades of colors. Yes, and on what grounds is it so loud anyway? A bit of theory and facts about Fast and Furious. We're talking about the air show on our channel. In order to figure it out, what is turbo mode? How is everything set up there? And at the expense of what physical and chemical processes, we managed to significantly increase the thrust. It is necessary to briefly explain, where does she even come from? Movement. It becomes possible for an airplane to be in the air and on the ground, thanks to the presence of jet thrust. It is created by turbojet engines. Which ones? They are throwing off massive streams of gas at a high speed, in the opposite direction of the flight of a winged machine. Everything is in order here. With Newton's third law and the law of conservation of momentum, the thrust magnitude of a turbojet engine is directly related to, depends on two factors: mass of expendable air and the speed of jet ejection from the nozzle. It sounds a bit dry and complicated, but it's quite clearly laid out. On a specific example, you can get the same craving with different values of these multipliers. For example, two completely different airplanes, passenger airliner A320N and the multifunctional F-16 fighter jet. Each of them has it on board. There is an engine with maximum thrust, approximately 12 tons for the passenger part of them too. But in this case, it doesn't matter. So, these 12 tons of thrust are created in different ways. The Pratt & Whitney F-100 engine on the F-16 fighter jet, it consumes about 110 kilograms of air per second. And he rejects the flow, hot gases in the afterburner mode at supersonic speed, while each CFML EAP-1 engine on the A320neo spends more 450 kilograms of air per second in takeoff mode. But the speed of gas outflow here is less than the speed of sound. That's exactly why power installations in modern ones, airliners, are so big and relatively heavy. But at the same time, they are more economical and quieter. An engine like this is absolutely not suitable for a fighter jet. He needs a maximally compact power installation, which can speed it up to supersonic speed. And due to its size, she simply isn't capable of having a large air expenditure. The developers of aircraft engines were able to find a compromise solution. They've finished it. He constructed it in such a way. What happens at the same mass airflow? It was possible to get more thrust. This happened almost immediately after the appearance of the turbojet engines themselves, back in the 1940s. But it's noteworthy. What is this device for the first time? Received the name Afterburner Chamber. Appeared on an experimental Italian airplane, Caproni Company N1. And instead of a turbojet, a piston engine was installed there. With a power of 900 horsepower, he put the compressor into operation, which supplied air to the combustion chamber. There, he mixed with the fuel. This mixture was ignited. I immediately burned out, and then it was ejected through the jet nozzle. This airplane first flew in 1941, but his flying career ended just a couple of years later. Reactive, the piston power unit was deemed unpromising. But the designers had a clear understanding. What if we replace the piston engine for a gas turbine engine? Then it will be a completely different matter. And already, in the 50s, the first serial jet engines appeared. Combat aircraft, which had a turbojet engine. Thrust chamber. The operating mode, with its activation, and accordingly, we started calling the increase in thrust as forçage. It's taken from the French language and it means coercion or intensification of something. Interesting, the French themselves don't use it in this context. They call it post-combustion. In a rough translation, the subsequent combustion, the word afterburner is used in English. The literal meaning is roughly the same. Since the moment of appearance of the afterburner on serial aircraft, it's already been more than 70 years in this time. Her construction has only become slightly more perfect. But the device and the principle of operation, we stayed absolutely the same. Afterburner chamber. Installed between the turbine and the jet nozzle. It's being burned in it. Additional fuel. The gas temperature is significantly increasing. And he is thrown out at a higher speed. It's formed in such a simple way. Additional pull. That is, the main purpose of the afterburner chamber. Giving to the outgoing flow of exhaust gases at a higher speed. Leaving it unchanged. Mass airflow at the engine intake. Maybe she's working because of that. What's coming out of it? There is a sufficient amount of oxygen. The thing is that in the combustion chamber of the gas generator, the process of fuel combustion, it's happening with a significant air excess coefficient. In a chemical reaction, less than half of the hydrocarbon oxidation is involved. Moreover, the vast majority of his volume, modern engines, that is, they have an external ring channel, where the airflow bypasses gas turbine installation, and does not participate in the combustion process, and also a quite decent volume of air. It is taken from the compressor, and it is used for cooling the turbine blades. So, there are no problems with an excessive oxygen. At the entrance of the afterburner chamber, there's nothing, but the main difficulty is, what is the gas flow from the turbine and the second circuit? It has a speed of about 200 meters per second and more. And the combustion speed, fuel-air mixture. In these temperature conditions, hold to orders of magnitude slower. And therefore, the organization of the process, the matter of combustion, is quite complicated. Installed at the entrance of the afterburner chamber, fuel injection nozzles. As a rule, there are about 1.5 to 2 dozen of them, and they are made in the form of thin rods. The nozzles are combined into one or several fuel collectors. If they want to have more flexibility and control, my fast and furious mode, at a short distance from the nozzles, the combustion stabilizer is located. He represents a set of annular and radial imaginary plates. As a result of a breakdown, zones are formed behind the stabilizer due to the flow of dry edges, back currents, and the problem of stable fuel combustion is solved in air mixture. To ignite the flame, they most often use powerful electric candles, or they apply the method of the firing track. When the flame, they are transferring from the main combustion chamber to the afterburner, right through the turbine. Combustion. Many engines truly have monstrous construction. For example, this Soviet product, the D-30, F6, but in some more modern models, they look different. In particular, this relates to the engines of American fighter jets, 22, and especially F-35. For the sake of stealth, they have, from traditional imaginary plates, flame stabilizer and rod fuel injectors. Most likely, these functions are combined in a single device, which also performs the functions of a radar for a bug. His shoulder blades can sometimes be seen through the nozzle. The temperature of the gas in the thrust chamber. It can reach 2000 degrees Celsius. And for protection against overheating, she has a cooling ring channel, He is educated by the wall of the building, cameras and heat shields, which are attached to the suspensions, to have flexibility during thermal expansion. This channel runs along the entire length, from the combustion stabilizer to the nozzle. For cooling, air from the external circuit is being used, or gas from the turbine. If this is a simple turbojet engine, they give the necessary rigidity to the screen. Cross and longitudinal corrugations. Perforation with millimeter holes provides air cooling, and larger ones also provide anti-vibration features on the screen. Properties. Periodic problems may occur in the combustion chamber. Fluctuations in gas pressure and speed, due to unstable vibrational combustion. Heat shields. They are made from hit-resistant alloys based on nickel. At the exit of the afterburner chamber, hot gas enters the jet nozzle. It plays a key role in the stable operation of the engine. When Forza is turned on, the nozzle expands, so that the pressure in the afterburner chamber doesn't increase. Otherwise, the engine will immediately begin to lose power, because it will decrease pressure difference at the inlet and outlet of the turbine. In reference literature, Fast and Furious mode, usually defined as a temporary way to increase traction. And in most cases, this is the absolute truth. However, there were and are airplanes in the history of aviation who could fly very long time on Fast and Furious. It was used on cruising mode. In this row, Soviet fighters, MiG-25 and MiG-31, as well as supersonic passenger airliner Tu-100, American experimental bomber X-70 Valkyrie, and the famous scout plane SR-71 Blackbird. In this row, he stands out especially. Could have been more than an hour. Maintain cruising speed. A little more than Mach 3. That is, fly 3 times faster than sound. The main problem of afterburner mode is that boost traction that way is happening due to an extremely high increase in fuel consumption, and basically, that is why it is designated as temporary. The following numbers speak for themselves. Increase in traction averages about 40 to 50%. A fuel consumption, it increases by about 3 times. For specific models, engines, these values may vary, one way or another. But overall, this ratio is most common. For example, engine IJ200, which one is installed on a fighter, Eurofighter, Typhoon, has a maximum afterburner thrust of 6T. And on Fast and Furious 9, that same 50% increase, while fuel consumption at maximum will be about 5,000 kilograms H, on Fast and Furious up to 16,008 per bar. Such engines have 32 T per hour present. That fighter pilot turned on Fast and Furious, quickly went up to the sky and not turning it off, flying low right here above the airpod. At the time of departure, the tanks are full. If it will be Soviet MiG-29, then, in this case, fuel in his inner tanks will end in about 6 minutes. More modern Eurofighter Typhoon will last in the air a little longer, about 8-9 minutes. And some are heavier. Twin-engine fighters will empty their tanks for about 10-12 minutes with height gain. Fast and Furious flight will last decently longer. Discharged air contains less oxygen, and less fuel is used for the combustion process. But fundamentally, problem, it's too high flow. Not going anywhere. For complete combustion of 1 kilogram of kerosene, almost 15 kilograms of air required. And it is with this proportion, this process takes place in afterburner. If you try to reduce fuel supply, that is impoverished mix. Its burning will take place slowly, unstable and with lower temperature. Gas flow rate if it grows, then quite insignificantly, and therefore there will be practically no increase in traction. By the way, color, afterburner flame, largely depends on the completeness of fuel combustion. If the process is as efficient as possible, then it will have predominantly blue shades. And yellow and orange colors indicate that fuel combustion is incomplete. carbon-containing products glow in this spectrum. Burning. The color of the flame can also be affected by air humidity and high dust content, as well as the technical condition of the power plant itself. It be like that sometimes. That engines, similar models on one aircraft, can have completely different shades of afterburner flame. And also in the dark or in poor lighting. The torch behind the nozzle can have a white-blue color, because all the fuel, as a rule, almost completely burns before leaving the nozzle. Then it happens because that there is no brighter light source with same radiation spectrum, that is sunlight. And still in the dark, the so-called Mach disks are especially noticeable. Gas jet outflow rate from the nozzle. In afterburner mode, supersonic, and the pressure in it is almost equal to atmospheric. Gas flow then shrinks, expanding by atmospheric pressure, and on the border between these stages are formed at jumps. Seals those same glowing rings or rhombs. As you move away from the nozzle, the gas flow rate drops, and they gradually fade away, and it falls very quickly. Turbulent mixing occurs. Gas installations with ambient air. And this process is the most powerful source of noise. At full fast and furious, the gas exit rate from the nozzle is more than Mach 2. That is at least 600 meters/second. Noise level when being near can reach 150 decibels and higher, while the pain threshold in humans averages about 120 decibels. Main source of noise, located in the initial section of the supersonic jet. 2/3 are emitted in this area. Her acoustic power. The afterburner chambers have numerous drawbacks. Among them, there is a high fuel consumption, high thermal visibility, more complex construction, and increased engine dimensions. However, the benefit of its use, covering all these shortcomings, the combat aircraft's capabilities are significantly enhanced, maneuverability, and many flight technical characteristics. Aviation is literally made up of compromise solutions, and the Afterburner Chamber 1 is one of the vivid confirmations of this. Airshow channel connection. Support us via the link in the description, and see you soon in new plots